Implementing packet captures on an ASA firewall. Let's begin. I'd like you to imagine that we have a user named Bob sitting at this computer right here. And Bob is making some trips out to the internet and reply traffic is coming back. And in the middle, we have an adaptive security appliance doing stateful inspection of all that traffic. Next, I'd like you to imagine that we need to gather or collect a packet capture for all of that traffic between Bob and whoever he's going to on the outside. Now, we have several options for doing that. We could put a protocol analyzer and capture the data right here on Bob's computer. That's fairly intrusive on the computer itself because we have to install the program and run it there. We could go to the switch that Bob's connected to and set up a span port and collect the data and replicate it to another port, and then have a protocol analyzer device capture all that data so we could analyze it here. Or if we have an adaptive security appliance as our firewall, one of the quickest ways is tell the ASA to go ahead and capture that data. Now there's two options in setting this up. We can use the ASDM wizard. ASDM is the graphical user interface for the ASA. Or we could use the command line and get the same results. And then once we have that data collected, inside of ASDM, we can actually launch a protocol analyzer like Wireshark to view that captured information, or we can download that captured information down to our computers either using a browser interface to download it or using a copy command right from the CLI. Now to do it inside of ASDM, we're going to do a couple of things. Number one, we're going to go to the Tools drop-down menu, and then we're going to select Preferences. And then in Preferences, we're going to specify the location of our protocol analyzer that we're going to use. In this case, I'm using Wireshark, so I simply point this to the application Wireshark. Now you might ask, okay, Keith, why exactly are we telling ASDM where Wireshark is? And that's because when we go to Wizards, and we go to Packet Capture Wizard right here off the Wizards drop-down menu, there will be an option at the end of this wizard to go ahead and run our protocol analyzer, our sniffer, against the traffic that's been collected by the packet capture wizard. So if our goal is to capture Bob's traffic as it goes out to the internet from the inside to the outside, we simply go ahead and click on Next. In the middle here, I'm going to specify that I want to lock it down to specific addresses. So I want traffic just from 10.1.0.25, which is Bob's IP address. And I'm going to specify a 32-bit mask, which in English says just that host. And regarding the destination IP address, I'm going to go ahead and say anywhere, which is what the zeros and zeros represent here regarding the destination, effectively going to any destination. Now also up here regarding the ingress traffic selector, I want to go ahead and collect this as it goes into the inside interface. And if we did want to go ahead and select, for example, TCP, and we just wanted to find HTTP traffic, here from the drop-down list, we could specify HTTP, and then that would match just on traffic from Bob's computer going out to the well-known port of 80. So in our case, though, I'm going to go ahead and select IP, which includes the entire IPv4 protocol suite. Not just TCP, not just UDP, but everything. Then I'm going to click on Next, and it's also going to ask us to collect data on an egress interface as well. So if we want to collect the traffic going outbound on the outside interface, so that would reflect Bob's traffic coming in on the inside and going out on the outside interface, we could select that as well. Click on Next. We can specify how big we want the buffer to be that's going to collect all this data. And if we use a circular buffer, it's going to be first in, first out once we hit that limit. In our example, I'm going to leave the defaults and click on Next. This wizard created the capture statements. It's going to match on traffic from 10.1.0.25 going anywhere. And it's doing that capture on the inside interface. It's also creating a second capture, which is looking for the same information, except in this case, it's applying it to the outside interface. Now, do we really need two copies of that same data flow? And the answer is no. However, the wizard is creating two captures for us, so we can pick and choose which one we want to use. So we'll click on Next, and then we'll click on Start to start the capture. Now in the background, I have a PC at that 10.1.0.25 that just sent a whole bunch of requests out to the internet. So if we want to take a look at the capture, we'd simply click on this link that says Get Capture Buffer, and it will show us the details. Now if we wanted to, we could use these saved captures and download them to my local PC, or we can go ahead and click on the Launch Network Sniffer application link, and that will launch Wireshark so we can see this data immediately. So let's choose that option. So here in packet 4, we have a DNS request for IP chicken. It looks like in packet number 5, we have a reply with a DNS response back from one of Google's DNS servers. If we wanted to implement the capture at the command line of the ASA, it's really simple. We go into configuration mode. For the capture command itself, we could either point to an access control list that's pointing out the traffic that we want to capture, or we could do the match statement right here in the capture statement. The syntax is very much like an extended access control list on the ASA. So here's the name of our capture, and we're matching on TCP traffic from this host going to anywhere. In this case, I'm going to limit it to traffic going to port 80. And this command simply enables the capture on the inside interface. We don't really need it on the inside and the outside. One copy of that data traffic from Bob going out to internet servers is enough. To verify that the capture is actually on, we can do a show capture. And that does a couple things for us. First of all, it indicates that it's currently capturing, and it's specifying the criteria of what it's capturing. If we want to start analyzing that capture, at the command line, we can do a show capture and then the name of our capture file. In this case, it's our-capture. And that'll show us right on the screen the contents of that capture. Now, how do we go about using Wireshark with this capture? Well, we need to copy it over to a location that Wireshark can use that file. So to do that, we're going to do a copy command. I'm going to use the /pcap to say I want to copy this in a pcap file format. And I'm going to go ahead and send it over to TFTP. So in the syntax, I specified the capture that we want to copy is our capture. So it's asking me to confirm that here. I'll simply press enter to confirm that. It's asking for the IP address of the remote host where the TFTP server is. We'll supply that. And it's also asking for what do you want this file to be on that TFTP server. And I'm going to call it ourcapture.pcap. And the extension of .pcap isn't required. However, it is convenient. That way, if you have a protocol analyzer on your local computer that's associated with pcap files, and you click on that pcap file, it'll automatically bring up the right program to open it. In my case, on my local computer, I use Wireshark. And then we'll press enter. And it wasn't very much data, so it is copied. So now that this file is successfully sitting on the TFTP server, I can move that file to my local computer or put it on a map drive and then open that file with a protocol analyzer like Wireshark. If security and protocol analysis is your thing, or you want it to be your thing, you may want to check out these additional courses over at CBT Nuggets. I've had a fantastic time with you in this video. Thanks for joining me. I hope this has been informative for you, and I'd like to thank you for viewing.